Hi, and welcome to That's Ready Mysterious. Join me for an intriguing look into real-life mysteries. Who was the mad gasser of Mattoon? What was whaling at the Wilga waterhole? I'm not going to solve those mysteries, but they'll be interesting to learn about. I'm your host, Kelly with an I. Transcripts and references for all episodes can be found at that'sreadymysterious.wordpress.com. No apostrophe and no exclamation point. Today's tale is about fast radio bursts, or FRBs. An Earth.com headline read, "Deep space radio signal reaches Earth after 8 billion years." Where did that signal come from? Fast radio bursts are powerful, mysterious bursts of radio waves that last milliseconds. The signal discussed in the Earth.com article was named FRB 20220-610A and was first detected by ASCAP, or the Australian Square Kilometre Array Pathfinder, on June 10, 2022. It is one of the furthest and most energetic signals ever observed. The energy emitted was equal to what our sun produces in 30 years, but happened in just a millisecond. The origins of FRBs are the basis for a great mystery. They were first discovered in 2007. FRBs are brief flashes of energy that are brighter than whole galaxies. They come from all over the sky with frequencies around 1400 Hz, although some have been seen with frequencies as low as 400 to 800 Hz. Scientists believe that there may be 10,000 FRBs in the sky over Earth every day. By the time FRBs reach Earth, their energy is 1,000 times weaker than a mobile phone signal would be if it sent from the moon and seen on Earth. Some FRBs repeat, but most do not. The nature of FRBs makes us consider our understanding of the universe. They can originate from places beyond our galaxy. They may be linked to magnetars, which are highly energetic remnants left behind after a star explodes. Magnetars are the most intensely magnetic type of neutron star. FRBs might come from quickly rotating neutron stars with powerful magnetic fields. They are also possibly linked to merging faint, dense stellar remnants of white dwarfs. It's also possible the FRBs come from collapsing neutron stars called blitzars. They could even come from colliding galaxies. For all we don't know about FRBs, we do know that their sources must have a lot of energy. As FRBs travel, they pick up information about their cosmic environments, like clouds of interstellar gas, for example. Dr. Stuart Ryder, astronomer at Macquarie University in Australia, used ASCAP to detect and track a burst down to its origins. He used the European Southern Observatory's Very Large Telescope to locate the source galaxy, which was older and more distant than any FRB to date. He said, "Using ASCAP's array of radio dishes, we were able to determine precisely where the burst came from. Then we used the European Southern Observatory's Very Large Telescope in Chile to search for the source galaxy, finding it to be older and farther away than any other FRB source found to date, and likely within a group of merging galaxies." FRBs could help us weigh the universe. There is a discrepancy between the amount of normal matter we can detect and what cosmologists think should exist. Could this discrepancy be outside of the visual spectrum? Professor Ryan Shannon says, "More than half the matter that exists today is missing." He says that if the missing matter may be hiding in spaces between galaxies where it's too hot and diffuse to see with normal methods. The ability to sense ionized matter in nearly empty space might allow us to measure the matter located between galaxies. This is known as the McCart relation and was started in 2020 by Australian astronomer Jean-Pierre Macquart. Dr. Ryder explained that the detection of FRB 20220-610A confirms the McCart relation, even for bursts that come from halfway across the known universe. JP showed that the further away a fast radio burst is, the more diffuse gas it reveals between the galaxies. This is now known as the McCart relation. Dr. Ryder said. Some recent fast radio bursts appeared to break this relationship. Our measurements confirm the McCart relation holds out to beyond half the known universe. To date, almost 50 FRBs have been tracked back to their origins. That's about half the FRBs discovered by the ASCAP telescope. Professor Shannon explained that FRBs are both common and hold great potential. He said they could be used to create a new map of the universe's structure and answer some big questions about cosmology. Researchers believe that missing matter may exist in forms that are hard to see, like hydrogen gas floating around an intergalactic medium. More recent research has begun to find these clouds. The Parkes Observatory found the first FRB that came from a satellite galaxy of the Milky Way. The signal was first detected in 2001 but was not found until 2007. This became officially known as FRB 010724. It lasted about 5 milliseconds and didn't repeat. It was one of the brightest FRBs to date. In 2012, the Arecibo Observatory found the first repeating FRB, FRB 121102. This FRB confirmed that some sources of FRBs survived their emissions. This was also the first time a telescope other than the Parkes Observatory found an FRB. FRB 121102 proved that FRBs are not a product of the environment the telescope was in. In 2013, the term FRB was first used to describe these events. The first FRB discovered was not the first FRB sent out. In June of 2022, astronomers using ASCAP found an FRB that came from 13 billion light-years away. FRB 20220-610A was the most distant FRB ever discovered, making it the earliest FRB ever sent. It possibly originated when the universe was less than 1 billion years old. Not all FRBs come from so far away, however. FRB 200428 was found in April 2020 by the Canadian Hydrogen Intensity Mapping Experiment, or CHIME, and the Survey for Transient Astronomical Radio Emission 2, or STARE-2. It lasted only 1.5 milliseconds and originated from about 30,000 light-years away, toward the heart of our galaxy. The longest FRB ever seen was FRB 2019-1221A, found on December 21, 2019 using CHIME. It lasted 3 seconds, which is 1,000 times longer than the average FRB. It had periodic peaks that repeated every 0.2 seconds. The discoverers compared it to a heartbeat. Since the first FRB was discovered, over 1,000 FRBs have been found. Until 2017, 10 years after the Lorimer burst, only 140 FRBs had been seen according to McGill University. This changed in part due to CHIME discovering 535 FRBs in 2021. Most of the FRBs found so far do not repeat. Of the 535 FRBs discovered in 2021, only 18 repeated. In 2023, using CHIME, the known number of repeating FRBs doubled from 25 to 50. Repeating FRBs are different from standard FRBs. Repeating FRBs last longer, but display over a tighter range of radio wave frequencies. Astronomers don't know what causes FRBs, but they do have some ideas. Because they only last milliseconds, they most likely come from compact objects. Light would have to cross the object in the same amount of time it takes for an FRB to peak and disappear. Some clues have led astronomers to believe that they originate from compact stellar remnants like white dwarfs and neutron stars. In 2020, FRB 200428 was traced to the magnetar SGR 1935 plus 2154. It also corresponded with a burst of X-rays. Magnetars would survive the emissions, so that could explain why some FRBs repeat. A collision of neutron stars would leave no survivors, so FRBs originating from those events would not repeat. A blitzar or collapse scenario would leave no survivors, so would also not repeat. A collision of white dwarfs could cause an explosion that would create an FRB. A collision of white dwarfs with neutron stars would create magnetars and FRBs. It's possible that FRBs all originate in the Milky Way but pass through thick plasma, leading us to believe that they come from further out. Professor Shannon says, "While we still don't know what causes these massive bursts of energy, the paper confirms that fast radio bursts are common events in the cosmos and that we will be able to use them to detect matter between galaxies and better understand the structure of the universe." What causes fast radio bursts? Do they all come from the Milky Way, or do some originate further out? What kind of understanding of the universe might we gain by further understanding FRBs? What do you think? Leave a comment and let me know what you think. Thanks for listening to today's episode of That's Ready Mysterious. Join me next week for another captivating mystery.